It's where you meet. Okay. All right. What's the formula for calculating standard deviation by hand? It's this one right here. Okay. What's the general rule for normally distributed data? It follows the 68, 95, 99.7% rule. If you don't have the percentages next to the numbers, that's fine, right? So to be more specific, it follows the, right, 68, 95, 99.7 rule. It's also known as the empirical rule. Okay. If you have empirical evidence, it means you have like data to back what you're saying. If somebody ever says, I have empirical evidence of what I'm saying, this goes back to stats, right? Data. What's the total value or area underneath the bell curve? You can say 1 or 100%. And the word area may have thrown you off, but area is also a way to talk about the percentages under the curve. Okay? For a normal distribution, what percent of data is less than the mean? That would be 50%, right? You think of your bell curve, the mean is in the middle, so 50% is less, 50% is more. Okay? Most popular shoe size reflects the mean, median, or mode. What do you think? It's the mode. Mode is the one that appears most often, right? The number that appears most often. So if you're keeping track of shoe sizes that you're selling as a store, you go by the mode, right? That's the most popular size that is being sold. All right, 1 mark for each. All right, so far. Draw a normal curve, and where your mean is 47.5, that's in the middle. This is my mean, and then 3 standard deviations to either side. So I already got it started. I kind of put it up on the screen before you guys were done, so some of you are like, oh, that's how you do it. So you go to where the mean is, you go to the top, make a little dot there, and then you just go down like that and try to make it symmetric. So I'll give you 1 mark for having the correct values along the x-axis. Okay? And I would give you another mark for filling in the rest. Okay, so you kind of want to, this is not, it has to be, doesn't have to be perfect. You don't have to necessarily use a ruler on this AC, but you put the percentages down, right? 34, 34, 13.5, 2.35, 0.15, and then you copy and paste on the other side. So as you move away from the mean, the chances that you're there are less and less, right? That's why the tails are starting to get closer and closer to 0, never touching the x-axis. That's by definition in statistics, these tails never touch. Because there's a chance, there's a slight chance that something is like way off, like an outlier on the low end or on the high end, right? So that's why we never make a touch. So state the value at -3 standard deviations. So we're looking for this value right here. So if it's the actual value, in this case it's 43 centimeters. State the value at +1 standard deviation. So this is +1, right? 1 standard deviation above the mean, that's 49. I didn't finish the marking guide here. So I would give you another mark for having all the percentages and having the label here. So 1 mark for the correct values along the x-axis, 1 mark for all the percentages and the unit, right? So we'll make this, we'll introduce 2 marks for drawing the normal curve, okay? So in total 2 marks for that one right there. So 43, 49. What percentage? So now we're asking for percent of data is less than -2 standard deviations. So less than this. So you add up these 2 values here. It's 0.15 plus 2.35. So that's 2.5%. Okay. If it's less than, then you want everything to the left. If it's more than, you would want to add all the percentages to the right. Okay. What percentage of data falls between -2 standard deviations and +3 standard deviations? So where is that? This would be -2, right? This one right here is -2 standard deviations, and +3 standard deviations at the very end, right? +3. So we want percentage that falls between here and here, right? All of those values underneath. So I talked about direct reasoning, where you add up all the percentages, or indirect. How is it indirect? 1, right, or 100% minus everything that's like outside of what you want. That's another way of doing that. So I'm going to show you the work here, so you should copy this down if you didn't get this right, or if you didn't know how to do it. Right, you basically add up all the percentages that are from between the two limits, so to speak, and that adds up to 97.35%. Okay. Or you go 100 minus 0.15 minus 2.35. Where did I get this from? These two sections here, and I'm also going to subtract this 0.15 on the other tail, this one here. So that's 97.35 regardless of how you do that. Okay. What percent of data falls between the mean and -1 standard deviation? So it's between mean and negative, so that's 34%, just like that. What percent of data is greater than 50.5 centimeters? 50.5 is right here, so percent of data would be these two sections combined. That's 2.5%, by the way. Just going to tell you what percent of data falls between 44.5 and 49 centimeters. So sometimes I use centimeters, sometimes I use standard deviations. So you got to be comfortable with either one. You also have to be comfortable with z-scores. Z-scores are essentially the same as, I could have said the mean and something that has a z-score of -1. Okay, so that's also the same. 44.5 to 49, we're talking about these three sections here. So I'm just going to give you the answer. That is 81.5. 81.5. So that is the end of the using that graph there, right? So this was almost from 6 to 12. That was all related to this. So 2 marks and then 1 mark for each. State the mean for the data on this table. What is this? This is technically a frequency table. Do you need to find the midpoints? No. There's no interval, right? So, but what you must do is make sure you put this into L1, this into L2. And then you go one variable stats, right? One variable stats, L1, L2, and your mean is 46.17. The standard deviation for this table, I'm just going to get it off of my previous there, it's 2.5 centimeters. The sample size would be this, right? That's where the sample size, and that's denoted by N on your calculator, and that's 18. We don't know what the data represents in this case, so we just know that N is equal to 18. That's the sample size. Okay. So we are out of 17 on this AC because of the graph. So it's 15, right? Except for we add 2 for the graph, so we're going to have this out of 17. If you want to put it at the bottom, that's just fine. And make sure your name and last name is on